Hi, this is the last part of the integration, which is the partial fraction technique. Before learning the partial fraction technique, you should know about the rational function, factoring, and completing the square. In this video, we will discuss about the rational function first, and after watching this video, you should be able to understand what is improper rational function and what is proper type, and how to convert from the improper to the proper type. So this is one of the important techniques in integration as well. So you can see that all type of the rational function can be divided into the proper and improper rational function based on this definition. So the definition for the rational function, you see a function with numerator and also the denominator. So we let the symbol n and d in this case. For example, let's say we have some function like 1 over x plus 1. So this is the rational function, right? Or you can have x over x plus 1 as well. So this is also rational function. Where for the left function here, this is called proper because it cannot be reduced further. And on the right hand side, this is called improper because we can further factor this into this, right? So we can convert the improper into the proper type. So this is the technique that you should acquire after watching this video. You know how to differentiate what is proper, what is improper, and convert the improper into the proper type. This is the definition for the proper and improper integral. This is the definition for the proper and improper rational function. If the highest degree of denominator d greater than n, then it will be proper. So if d less than n, then it will be improper. So let's see for this case. So the d at the bottom, the highest degree is 1, right? At the top, the highest degree, okay, since it's a constant is x to the power of 0, so it will be 0. So in this case, d equal to 1 greater than n equal to 0. So this is the first case, is a proper rational function. How about this? So for this case, the d is equal to 1, and at the top, the n, the degree also the same, is equal to 1. So d is equal to n in this case for the degree, therefore it will be improper rational function. We have more example here. So you can see that the degree at the bottom is 2, u to the power of 2, so the degree is 2. At the top, the degree is 1. So in this case, it will be proper rational function. Okay, because we cannot further reduce it, right? For the improper rational function, let's say you have this case where your degree d is 2, your degree n is 2 as well. So in this case, we say that is improper rational function, right? Because you can further reduce it. So last case, okay, at the bottom degree of d is 2, at the top degree is 3, right? So there's a typo here, it should be greater than, 2 is less than. So in this case, it will be improper rational function because we can further factor this, right? You can see that for the proper rational function, it cannot be reduced further, right? And then for the improper rational function, we can further reduce it to the proper type. In integration, if let's say you have rational function like this, you want to integrate it with respect to u, first thing you need to check is whether the rational function is proper or improper type. If this rational function is improper type, then we have to reduce it to the proper type first. So which one of the integrand is the improper rational function? Please identify. So the hint is for the improper type, okay, we can further reduce it, right? By using factorization. Or we can say we can further factor it. For the first case, you can see that 2u at the top, which is the degree is 1. The degree, highest degree is 1 at the bottom as well. So this is improper case, and we can further reduce it. And for this case, although the u here is power of 1, but you have to be careful. This is u to the power of 3. So the highest degree is 3, u3. And then at the bottom, the highest degree is u1. So this can be further reduced, right? So this is improper as well. So far we have two cases is improper. Then for this case, the highest degree is u3, and this one is u4. So we cannot. This is the proper type, and we cannot further reduce it, right? Because it's already at the proper type. So this one is u to the power of 2, and to the power of 2 here, in total you get u to the power of 4. So the maximum degree is 4 at the top, at the bottom is 4 as well. So this one we can further reduce, which is improper type as well. So you can see this is the highest degree. For the denominator d and nominator, where you have 1, 1 here. So as we discussed, this is improper. So for this one, we have nominator n 3, and at the bottom is 1 here, right? So this is improper as well. So this one, the d is 4 at the bottom, n is 3 at the top. So this is proper. And lastly, 4 at the bottom, 4 at the top, right? So this is improper. In this slide, you will learn how to convert the improper function to the proper one. So for example, if you have a function like this is an improper rational function. How can we convert to proper type? The answer is by using the long division. So x to the power of 3 plus x to the power of 3 plus x here. You should have a polynomial function from x to the power of 0, which is the constant, okay, and then x squared, x to the power of 4, x to the power of 3. So you divide it or factor it with respect to x minus 1. So we have to multiply x squared, okay, x squared you multiply, and then you get x to the power of 3 here. X squared multiply negative 1, you get this. And then you have to minus the term here. So x to the power of 3, it becomes 0 when you minus it. And then this one minus, you get positive x squared. So the x remain. And you continue multiply with x, you get x squared. X multiply negative 1, you get negative x. Then if you minus this term, and you will get negative become positive, you get 2x. So this is your remainder. Therefore, we can write the format into this, where you can see x squared plus x here is this term, and then the remainder we put here divided by the factor x minus 1. So you can see that 2x over x minus 1 here is also improper, because the degree x to the power of 1, x to the power of 1 at the bottom also. So we can further reduce this by using long division. By using similar approach, 2x we put inside divided by x minus 1 at the outside here. So 2 multiply x, we get 2x, so we can cancel this term. 2 multiplied negative 1, we get negative 2 here. So you have to take the 2x minus with this whole thing, and then what we have is 2. So 2 is our remainder. Therefore, we can write, okay, into this form, x squared plus 2 plus x remain, and this term can be further reduced to this, which is written as 2 plus 2 divided by x minus 1, which is this one. And we can see that this cannot be further reduced anymore. So why we want to do this, imagine that if you want to integrate this term, it will be complicated for you to continue, right? So what we can do is we identify this to be improper. So once you identify it, you should reduce it into the proper form. So once you reduce into this form and you want to integrate it, it will be much easy, right? Because this is a polynomial function, and this one, the result, we can form the substitution and then solve it, you get something in ln. I mean the ln function, where you integrate this component, you should get 2 ln x minus 1. Or if you can let the t equal to x minus 1, you integrate accordingly, you also can get the same answer. Right? Next, let's try with more example. As you can see, this is improper function where you can have a degree equal to 2 at the top and degree 2 at the bottom. So we want to convert to proper function. We have to use the long division. So in this case, we let the top inside here and the bottom, which is the factor. So we multiply 1, so you get 4x squared. So this whole term can be cancelled. So 1 multiply negative 4x, and you should get negative 4x here. 1 multiply 3, you get here. So you should minus it so that this whole thing becomes 0. And this thing, after you minus, you get the remainder, which is x minus 1. So your final answer can be written in this way. 1 plus the remainder x minus 1 and divided by the factor here. So you should be able to get this answer into this form. Now we success to change the improper into proper rational function. And you can see that this term we cannot reduce further because the degree is 1, and at the bottom you have degree equal to 2.